Sketching a rational function. Let's say we have a function f of x is equal to x plus 3 over x times x minus 3. So first of all, we are looking for the axis of symmetry. If we look in the axis of symmetry for this function here, we already see this is x plus 3. But then is x times x is x squared minus 3x. This function is not even, neither is odd. So it's neither odd or even. So it's not symmetrical with respect to the 0, to the origin. Neither is symmetric with the y-axis, with respect of the y-axis. So this is a neither. So for the axis of symmetry, it doesn't have. So now let's see and let's find the other points here, other important points. So just let me take a pen. The other important points, let me go first of all, let me take here let me take a x-intercept. X-intercept, let me write x-intercept. If x-intercept y is equal to 0, so I am setting y is equal to 0. If we are setting y is equal to 0, and here we write a 0 is equal with x times x minus 3. Okay, its denominator is x minus 3, and numerator here is x plus 3. But if we are multiplying everything, hold this equation, by x times x minus 3, so x times x minus 3 is going to disappear, and from this is going to imply 0 is going to be equal to the x plus 3. And if it's x plus 3, we already see here x is equal to minus 3. So here's the x-intercept. So it means x-intercept is minus 3 and 0. Y is 0. And minus 3 and 0 is here somewhere. Let's say this is the x-intercept. So I am plotting in here. And second is the y-intercept. If we are looking y-intercept, I'm going to set x is equal to 0. Everywhere x is going to be equal to 0. Now if we are plugging here f is equal to 0, then f of x, so f of x or y, is going to be equal, instead of x I'm plugging in 0 everything, it's 0 plus 3. And then is 0 times 0 minus 3. As we see here, this is undefined. So what happened to be here is going to be 0 plus 3 is a 3. And here is 0 times 0 minus 3 is a 0. So this is undefined. So y-intercept is undefined. So it doesn't have y-intercept, or is undefined. Let me write undefined with abbreviation here, undefined. So f of x is not going to intercept in the y-axis. So what we are going to have next, we are looking for the vertical asymptotes. If we are looking for vertical asymptotes, we already see here, taking the denominator, and the denominator is x times x minus 3 is equal to 0. So we already see here x is going to be equal to 0 and x is going to be equal with 3 with 0, and x is going to be equal with 3. So those are the asymptotes. So here I am not writing when is the y-axis is the asymptote, vertical asymptote, and the other is 3. Let's say here is 2, here is a 3. So let me draw the other vertical asymptote here. So this is the vertical asymptote. And now if I'm looking for horizontal asymptote, horizontal asymptote is going to be, now because of the function here, x plus 3 is x squared minus 3x, and if we look in here at the degree of a numerator with degree of denominator, the degree of the numerator here is lower for 1 degree than the degree of the denominator. That's why the horizontal asymptote is y is equal to 0. So it's going to have a y is equal to 0 according to the definition of the horizontal asymptotes. Now, we already have, here is a 0, but here we have an asymptote. And now we want to know in this region, and we want in the 5, I need the other points here, important points, to know between infinity and 5. If I'm plugging a number, doesn't matter which number, let's say from the region minus infinity and to minus 3, I am taking any number and I'm plugging here in this function. And let's say minus 4 plus 1 is minus 1, here is minus. But here is a minus 4, minus 3 is a negative, and the minus is a positive. Negative over positive is going to be negative, so the sign is negative. So because the sign is negative, is going to be down. But as we see here in the graph, what's going to happen in the graph of the asymptote, horizontal asymptote, always the graph is going to be very, very close here. Very close is going to be, as x goes to infinity, this is going to be very close with the asymptote. The graph and the asymptote are going very close to each other, but they are not going to touch each other, but very, very close. But here is an intercept. Here has to intercept. And if it has to intercept here, and if we are looking, for example, minus 1, if we are plugging here, minus 1, and plus 3 is in the region, for example, from minus 3 to 0. We are going to see is the graph positive or negative, from minus 3 to 0. From minus 3 to 0, we take in any number. If we are taking minus 1 and plug in here, minus 1 plus 3 is plus 2. And here is negative 1. Here, negative 1, negative 3 is negative 4. Time negative is a positive. But here is a positive over positive is positive. So we see the sign is positive in this interval. And we already know, and here is intercept. It tells us the function is going to intercept this point and is going to change the graph. But as we see here, it's going very, very close, but we don't have an intercept because the vertical asymptote here, we have a vertical asymptote where x is equal to 0. So x is equal to 0. Vertical asymptote. The other horizontal vertical asymptote here, we have x is equal to 3. X is equal to 3. So those are vertical asymptotes. And now we are looking here the graph. Where is going to happen the graph? Is going up or is going down? That's what we know. And we know as the graph goes down, is going to go near the asymptote, of which, or if it goes up, goes near the asymptotes. But we need just one point to know here. In interval between 0 and 3, if we take in the interval 0 and 3, we take any point here, 0 and 3. We take a, let's say, is 1. We take a 1. If we take a 1, 1 plus 3 is 4. And here is a positive 1. And 1 minus 3 is minus 2. On the top is a positive, but down is a negative because this is a negative here. Here is positive 1. But the time of minus 2 is a negative. So the function has to be down. We don't know exactly. We are going approximately where it's going to go. And what's going to happen here is this function. This function is going very, very close to the asymptote, but it's not going to touch. Same thing is going to the other asymptote. Very, very, very close. So this is the graph how it looks. And now we look in an interval here. But as we see here, whatever number we are taking, in the interval between 3 and infinity, whatever number you are taking is going to be positive number. If we are taking, for example, 4 plus 3 is 7, 4 minus 3 is 1, and here is 4 times 1 is 4, positive over positive is positive. So here is a positive. Just let me write, and here is negative, was from 0 to 3. So there's negative, and this is a positive here, okay? And this is a positive here. So in interval from 3 to infinity is a positive, and graph of the function is going to be on the upper side, and as it goes down, it's going to go very, very close to the asymptotes, and very close to the other asymptote here. So this is a graph of the function, how we can sketch it. But if we want to be more precise, we can draw with the Desmos, and Desmos has this kind of the graph.